Okay, we can start. Good morning, buongiorno, bom dia, buenos dias, dobry dzień, assalamu alaikum, and welcome to this last appointment with the Ocrim webinar about the Modular Mill Concept. Our relator will be Marco Galli, our Chief Technologist, and I'm Anna Buffa. I'm a food entertainer, and I will be moderator of this webinar. I work in the communication field, food, since 15 years. And so I will moderate your question and answer moment. About the webinar will last 1 hour, including questions and answers. About the question and answers, you can write your questions in your field that you find in your screen, and we will read after the first part of the webinar, exactly in the middle, and at the end of the webinar. All the questions are in anonymous form, so don't be shy. You can ask everything you want about the MMC. And if the questions will be very long or very complicated, don't worry, our relator will, our speaker will answer you by mail. Our mail is conferenceroom@ocrim.com. So now a brief presentation of our dear Marco Galli. He works in Ocrim since 1983 as a miller apprentice. He started his career exactly in that year. In the early 90s, he began technology manager of the largest milling complex in the world, Bogasari Flour Mill in Indonesia. In 26, Ocrim began headmaster of Ocrim Milling Technology School, and he is very known for his continuous research of new application in the milling field, having patented inventions filed in his name. Recently, he has managed the technological design of the milling complex, which will be built in Cremona, which name is the Milling Hub. So I'm very pleasure to introduce Marco Galli. Buon pomeriggio, buongiorno Marco, welcome.
Buongiorno Anna, thanks for this nice introduction. And again, good day to all and welcome to this Ocrim webinar. As anticipated by Anna, today I would like to introduce this new concept about the modular mill concept with some highlights on how this concept works. I hope you will enjoy this hour with us, and in the end, we will be happy to attend on this seminar. So, in order to understand the principles that there is behind this technology, it's important to understand and analyze the tendency that we have in today's market. Because this one will drive certain tendency, and then we have to understand also why we have those tendencies. So, the analysis that we did and the evaluation behind this analysis are showing that the high capacity plants are one of the trend worldwide. Why we have this tendency and why the market is moving to that direction? The main reason is the overhead cost reduction, which is one of the main drivers in today's mill production or mill industry. Overhead cost reduction involves many segments. Just a few examples: manpower, energy cost, production, productivity, maintenance. Those are just some examples that together complete the overall cost on the plant. And this is something that with the technology that we have today, we can help to reduce. So entering into details and showing some indications, we could start from manpower cost. We all know that a ratio between a capacity mill and manpower is less in a big mill. So this means that a big mill has less person related to the capacity compared to the small mill. And the reason is very simple, because we can optimize the resource, the people and the manpower. And this It's one reason why higher capacity plants becomes more attractive. Roughly speaking, depending on the regions, depending where we are, the cost related to the manpower is rated between 8 to 16% without considering the raw material cost. So any reduction that we will have in the end related to this segment, it could be an important reduction. Another important point is the maintenance and maintenance cost related to the production. Considering the initial investment to build a new plant, it's important to maintain that plant in the good shape along the years. And to do that, we need maintenance. We need to do periodically maintenance, but everybody knows that sometimes maintenance is, we have to compromise maintenance and production, one of the two, because sometimes production needs to produce to satisfy the market demand, and we have to compromise maintenance. So we know also that if we don't do maintenance, we can have a plant not as we expect. The reliability, performance could decrease. So it's a trade-off, it's a balancing between these two aspects. And this is a point that is even more complicated to manage and to balancing if we go to big mills. Another point that is easy, this is easy to understand, is that the high capacity mill optimize economy of scale. And economy of scale is something that, or optimization of cost in the CapEx is something that all the investors are looking in details. If any one of the investors can reduce the original CapEx to build a new mill, they are more than happy. Just an indication, if we compare a 600 tons against 2 times 300 tons, we have a difference on the initial CapEx about 15 to 20%. Of course, 600 tons is more attractive. And this is another aspect that drives the market to the high capacity plant. Another aspect that is not a direct cost, but will impact on the CapEx as well, is two-line needs more space, needs more infrastructure. So also this one, if it's even difficult to understand or to quantify, but it's another aspect that involves in the decision which one is the best approach. And then also, as we start seeing from the maintenance and manpower, we have an indirect reduction on manpower and in the energy consumption, because those aspects we can optimize. High capacity plant is easy to optimize compared to two small line. So those are just examples on how big plants are easy to optimize aspect. Another point is that in order to have a very reliable production, large mill needs some help, let's say on that way. What do we mean for run smooth? We need consistent finished product, we mean consistent finished product and reliable production. And to obtain that, we need some help. Help that today we have the technology that can help the operators, help the millers to obtain these two tasks. And this is possible, join automation together with digitalization, together with the Internet of Things. One example could be a production change. Automation could help to reduce the time for the miller's activity during all these changes. And in the same time, will guarantee that all this procedure, the procedure that have to be doing to change from one production to the other, has been done on the proper way, without any human mistake or human error. Digitalization came when data are important. For example, extraction rate, or all the data related to the new production and the target of the new production. So saying when we are okay, when our flour is already respecting all the parameters or all the specification. Internet of Things. Internet of Things is the technology that allows to close in a connection many devices or sensors. And in a flour mill, one of the most clear example for that is roller mill, but also NIR control monitoring. For example, control on protein blending, loading, the cleaning or the milling section, finished product quality. So those are all the devices that can be integrated and the data can be utilized for helping the miller. Those technologies that we briefly mentioned are the technology that we are using today in a recent plant that we built with a capacity of 1,200 tons, 3 times 1,200 tons. So it's not 3 single lines that together make 1,200 tons, but they are 3 times 1,200 tons, so 3,006 in the total. As you may know, large or big mills has also some limitation. Stop the mill for any reason is always a concern, but as we saw in the beginning, we need to do maintenance if we want to keep performance, productivity, and so on. For example, we need to stop the mill to change socks in the filter. We need to change rolls. We need to do periodical maintenance in sifter, cleaning and inspection. And today, with today's technology, we have to stop all the mill just to do this maintenance or just to do those activities. When we stop the mill, doesn't matter for which reason, it's a cost that drives you to lost production, or is a cost related to a loss of opportunity to produce more with less, opportunity to optimize the time, opportunity to optimize manpower, opportunity to create new markets. All the above points drive to a profit loss, because when we lost something, in the end, we lost profit. Consequently, we will impact the balance, the economical balance, and this reducing, in the end, competitivity. So those are the trade-offs between high-capacity mills and a benefit and, let's say, concern that we have. In fact, those are the pros and cons that we're having with high-capacity mill. And this balancing is the reason behind then our idea on develop this new modular mill concept. Our goal in the end is very simple, is to maintain all the benefit related to a large single line without the limits that we have with a single line. So we try to limitate any impact related to the concerns that we have on the high capacity single line. Other proposal, other goal that we have on using the modular mill concept technology is also to simplify the all-by-day activity that we have today in a flour mill, increasing with that one at the same time productivity and consequently the economical balance. Now, before to go in details and explain what is a modular mill concept, and in order to understand also why we have those benefits, it's important to understand what modular mill concept is not, because there are some misinterpretation on that one. So it's really important to understand what it is not. So we will start for what modular mill concept is not. It is not a combination of two single lines. For example, we are not considering 2 times 300 tons independent line to have in the end 600 tons per day line. It's not two single line with a common cleaning system. It is not two single line with a common finished product collection. We are not considering to save some blowing lines and some screw conveyor. It's not that the idea that we have in mind. It's not the technology that allows to run two different types of wheat in the same time. It's not that one. We are not talking about two lines. This is not the technology that allows the mill be economically running at low capacity. It's not that one. This is a 600 tons that has to run the 600 tons. So in conclusion, we are not considering any type of two single line, but we are introducing a new concept for a high capacity single mill. So saying that, what is modular mill concept and what makes so unique this technology? Basically, modular mill concept is a single line, so back to the example before, is a 600 tons divided in 3 groups interconnecting to achieve the full capacity. So if I want 600 tons, I have to have all the 3 groups working together. The 3 groups are divided in 2 independent groups that we can call group 1 and 2, and 1 single and 1 common group that we will call group number 3. With this configuration, modular mill concept allows to stop alternately group 1 of the 2 independent groups, enabling the system to run at 50% of its full capacity, without any impact on the remaining group of the mill. Of course, also without any impact in the finished product. When I say any impact on the finished product, I mean any impact on dash, contain, on extraction, and so on. So we just stop one part of the mill while the rest is still running. Vice versa, when we stop the common group, all the mill will be down. To better clarify, when we say stop one of the 2 independent groups, we mean both suspend the production and switch off the equipment related to that group. With the equipment switched off, maintenance can be easily done, and all this without any impact on the remaining group. Now we will try to visualize this concept, and to do that we could compare the modular mill concept to the gear wheel transmission. So here we can see by different color, group 1, group 2, and the common group. If, for example, we imagine to stop the group 2, the blue one, we will still having group 1 plus the common group, which are producing at 50% of capacity. On the other hand, if we stop the common group, the equipment 1, all the mill will stop, as we have today. The only difference is that one. Today, anything happen in the mill, you stop 100% of the capacity. In our case, most of the time, if something happens, you will stop just 50% of your capacity. So I hope this start to make more clear how the technology works and the benefit that we have. Saying that, summarizing, the technology allows to do maintenance in one part of the mill while other parts are still running, with the benefit to have 50% of the target production. It's important to highlight that in this condition, all the sequence that drive to have 50% of the mill, 50% of the production, and maintenance in the same time, all the sequences, all the safety devices are fully automated. In other terms, we have to respect and to guarantee the people or the crew that are doing maintenance that nothing happens. And this is totally automated. This also is totally automated without any intervention by the operator. So any event that happens in the mill will react itself. So the operator does not have to be present all the time to follow what happened in the mill. So this is, I think, and according to us, is a really important step in order to allow the operator to do more activity and not be just concentrated on what is going on in the mill. To try to clarify even more this concept, this slide are showing how the equipment looks like under which group. This is an example where we can easily identify by color the three groups. So yellow, the first independent group, blue, the second independent group. So when I say independent group, I mean that yellow can stop alone, leaving blue running and vice versa, while the red one, if stop everything. Considering that according to the size of the mill, and so we can consider in group 1 and group 2 also purifier, brand finishers, equipment that are not showing in this drawing, because the main concept in our technology is the one that stop the equipment or apply the modular mill concept to the equipment that where we need to do maintenance, we have to stop totally the mill, sifter, filters, and plants and roller mill. Another information, the concept of modular mill concept can be extended also to the motor control center in order to extend also the electrical equipment, all the benefits that we have on the modular concept. Of course, this which we are seeing here is a erection drawing related to a 600 tons mill, 650 tons mill, which is running today with this concept. As we say, with group 1 or 2, yellow or blue, in any moment we can stop and maintaining a capacity of 50%. This is the main features that we have with modular mill concept. And of course, with the red one will stop everything. And is what happened in today traditional mill. One of the goals that we have is the one that reduce as much as possible the equipment under group 3. And this to reduce by chance, by probability, the needs on maintenance and unforeseen stop related to the group 3. So the probability is less compared to the other group. So we try to optimize what we will have under group 1 or under group 2. Always when we stop and running half capacity, we are running without any impact on the finished product. This is really, really important to remind. As mentioned already, the purpose of the modular mill concept is to have, during maintenance and unforeseen stop, at least a partial production. Today, any shutdown, even the one not correlated, any shutdown we have, will create a total production suspension. One example to try to clarify this concept. During the maintenance of a sifter, for example, millers, they never open all the sifter at the same time, especially in a big mill. Millers do maintenance in one, maybe two sifters, while all the other sifters are staying stopped and nobody is doing maintenance on that one. And the reason why this happens is because there is not enough manpower to do maintenance in all the system. Just imagine 600 tons, as we see before. If we stop all the mill, we have 6 sifters where people are working in 2 and the rest are untouched, let's say, on that one. With the technology that we are suggesting, that we are proposing, we will have 2 sifters where people is doing maintenance and the other 4, they are producing. They are producing and they are reducing cost in the end. The same happens for the roller mill. During the roller mill, the rolls change, or the filter when we change socks. So, become easy to imagine the benefit on the modular, or the benefit that modular mill concept gives on the production related to the maintenance. The same for the energy consumption, where a suspension creates a continuous consuming energy compared to have the mill at least producing 50%. Those are just 2 examples, but the example can be extended. This technology, of course, bring us to a new maintenance organization and scheduling approach. Maintenance could be scheduling according to the real need, considering that we are not having the total mill shutdown. Crew will have the proper time to do their maintenance according to the procedure they have to follow. There is no rush to finish, because one characteristic point is we have to rush to close the sifter because we need the production. With this concept, we still having at least 50% of the production. So this will relieve a little bit the operators and give them the time to do the maintenance on the proper way. We are focused on maintenance, but in the same time, we can apply the same benefit for the unforeseen shutdown. One clarification. As you may understand, this concept is applied for the large capacity flour mill. And the break-even is founded in a mills about 500 tons per day. Of course, we can apply on smaller capacity, but really then we have to start to understanding if it's useful and if the return of his investment is reliable and viable on that one. So now I would like to pass the line to Anna and see if we have any question from the audience in order to start to have all the people participating. So Anna.
So yes, thank you. We have some questions. The first one is half a consideration and the second part is a question. So I agree with the economy scale in the high capacity plants, but what about the wheat milling changes and the lost time adjusting machinery?
Okay, this one is right, but we will see in the next part of the presentation that this technology, as we say, is balanced together with some equipment with new philosophy. So the equipment itself has to be capable at least to give some indication to the operator on how the equipment has to be set. For example, roller mill. We will see. We need to move also to the new standard equipment, so to the new features in the equipment. Of course, if we apply new technology, also new equipment has to be applied together, because otherwise we will have some benefit, but as you mentioned, when we retrofit, when we have changes, we will lose time on doing those changes in the production, for example. Mm-hmm. But automation, digitalization, Internet of Things helps on that one.
Okay, thank you. Which equipment is in the common group?
We have roller mill, sifter, and filters in all the three groups. So it's just a matter on how those equipment are loaded. We will see in the next part of the presentation how we split this one. But all the equipment is distributed. The key point is reduce as much as possible the equipment under group 3.
Okay, how do you keep flour quality granulation within quality and functional specification when 50% capacity is reduced? And are the purifiers and sifters also zoned with the rolls?
How we manage the quality? We manage the quality related to capacity. So we have the two main groups, individual main groups, 1 and 2, which are in the head of the mill. So in this one, we have to balance it exactly, quantity and quality. And we can do that with the proper flow sheet. So when we decided to stop, we stop not half of the mill, we stop part of the mill, which is a dedicated capacity, dedicated quantity and quality, but we stop everything together. These two main groups, they are not connecting each other. So what we stop in one group, it does not affect on the other one. Something will happen on the group 3. So we are totally independent. And this is the way that we manage the quality of the products.
Okay, thank you.
And we will see that more on the details on the next slides.
Okay. Did you test yet this technology? And
yes.
How many people worldwide are using this technology?
We are presenting this technology on this week, but we have this technology running since from more, I would say, 3 years almost. We will see some picture where this technology is applied. So this is a proven technology. We don't have this technology just on paper. We have this technology which is really running in the day-by-day production. And if you are interested, we can visit those mills. The customers is really open to show this technology and the mill that are using this technology.
Another one question. Is it mandatory for the mill to produce over 500 tons per day in order to consider a MMC?
It's not mandatory, but this is the balancing that we found. Because in order to be competitive as a technology, we have to have a minimum equipment. If we are too small, there is no benefit on using that one. For example, if your mill has one single sifter, there is no way to do a modular mill. You know, you stop one sifter, you stop everything. So we say the break-even is founded in 500 tons, more or less. But we are open to analyze less capacity mills if see how much we can apply of this technology, because also we can apply on different steps.
If you don't want to have quality oscillation, it means that the group 2 and the group 3 have to be symmetric as machine list, isn't it?
No, group 1 and 2 has to be symmetric. Group 3 is totally independent. So we have to have same equipment list, same equipment configuration, same equipment load on group 1 and 2. Group 3 is another independent group.
Yes, he corrected himself. You want to say this, exactly. Okay, I suppose we should go on. And
Perfect.
After we will have the last session at the end of your presentation. Thanks.
So Now, back to the presentation, just one small, the picture that we are seeing is a mill, 1,200 tons, using the technology that we are speaking about, just for your reference. So now back to the presentation, an aspect that for me is really important is the impact of Industry 4.0 in the modular mill concept. Today, everybody is speaking about Industry 4.0. But I think this is a real example on how we apply the Industry 4.0 to our industry. A millware operator supervises the mill and the equipment from anywhere just with the simple smart device. The mill that reacts according to an event without any operator intervention. The millware is possible to stop part of the equipment doing maintenance while the other parts still running and producing. If we adding to that a real data exchanging, like extraction rate, wheat and flour quality, quantity, stock monitoring, production planning, and equipment status or information, so all these filters and having all these features based on friendly system that helps the operator, guide the operator to take the right decision in front of events and reducing the potential human error, I think this is a good example on Industry 4.0. Now, how we achieve this concept? So to have this concept and to realize this concept, we need to put together all these three items, segment these 3 points: flow sheet, layout, digitalization, and equipment. Without the combination of these 3 elements, we cannot get the modular mill concept. So flow sheet concept. Flow sheet concept starts on how to load the 2 single independent lines. So we will start these 2 single lines with 2 independent scale, one for group 1, one for group 2. And this is because if we need to cut the load, we can cut independently one to the other, allowing to run 50%. Second challenge is how to balance the load between these 2 groups. So now having a 50% load in group 1, 50% load in group 2 is easy to understand that we can balance easily the load, and on this one maintaining the quality, the flour for the finished product. Third key point on the flow sheet is reducing as much as possible equipment under group 3, because reducing equipment under group 3 will reduce the possibility to stop everything, to stop all the mill for any reason, maintenance, unforeseen stop. So this is the third challenge, and this is all under the flow sheet. Of course, flow sheet is a concept. Then we have to realize the flow sheet, and this is the reason why we need the layout. So the layout is what realizes our flow sheet. We have to identify in the layout the proper position for roller mill, sifter, single channel, and so on, how to load the roller mill with the load from the sifter and vice versa, where to put the specific passage to be easy loaded, and to create a simple layout, considering that we want a simple layout, a clean layout, because no one wants pipes crossing from one side to another. So this is an aspect, and the layout has to considering also, for example, the division, the distribution between the pneumatic. We have 3 groups, which in the individual pneumatic system, which has to be developed for each specific group. So layout has to consider all this aspect. And today we can do that thanks to the close interaction that we have between millers, between engineers that is working on the process, because the layout really is one part of important aspect that we have. Then becomes the digitalization. When we say digitalization, we are combining some aspect, as we already saw, automation, Internet of Things. And digitalization in a concept like this one is maybe the most important one, because someone from you already asking how the equipment, how we can speed up the changes. Speed up the changes can be done only through the digitalization, together automation, together Internet of Things. Just one example, guarantee all finished product quality specification with 50% less. And when I say guarantee quality specification, is not just ash, it's ash, granulation, absorption, so whatever is included in the specifications. Supporting the operator on their decisions related to the quality aspect or unexpected shutdown. Define a maintenance schedule according to the real working hours for each single equipment. Also, safety devices, safety environment for maintenance. Don't underestimate this point. We have part of the mill running and part of the equipment which could be under maintenance. So all this is something that can be obtained between a combination of automation, data exchanging between equipment, and here is where Internet of Things technology helps. And now we came to the equipment. One example for that one. Equipment is related, for example, to the roller mill. Now, just a second to update the slide. Yes, equipment. So, considering the data exchanging between roller mills and between roller mills and SCADA, considering that this can be done today, just interconnecting the equipment through a smart device that will be connecting with SCADA, with the goal to exchange all the information on settings, information on performance of the mill. And this is possible thanks to data collection. Staying with the roller mill, one of the examples that data can be exchanged is, for example, the amps of the roller mill, which gives you a lot of indication. Also, the roll temperature are other indication that we can get, that can be elaborated. So, in the end, new technology needs new features in the equipment, and this is what we are talking about. So, we can have those technologies today applied to the roller mill. Modular mill concept has a lot of benefit that is tangible, is easy to see, and is immediately seen. But we have other a benefit that is not so clear. One example is the erection erection and startup. When we invest in a mill, the erection time and the startup is always a concern because it's a quite long operational activity, let's say. With the modular mill concept, we can reduce that time because we can do erection by phases, starting from, example, group 1 and group 2, start this part of the mill at 50% of the capacity, and then conclude the erection with the second group, independent group, and then have a full capacity. In our estimation, the experience that we have, this capability allows to reduce direction and to start a production with a reduction of 20 to 30% of cutting in the time compared to what we have in a standard mill. This is another indirect benefit that this technology has. Some of you are for sure asking, is the modular mill concept technology can be applied to the existing plants? Yes, in principle, the technology can be retrofit. Of course, a survey has to be done because we need to understand how is the existing mill, how is the flow sheet, how is the automation, if the layout has some limitation. But in the end, in principle, yes, it could be done. Of course, it's something that we have to sit together and understand how we can monitor and how we can understand up to the point you apply the modular mill technology in your reality. So we say many times, modular mill technology is nice, modular mill technology is good, and so on. Let's convert these to numbers. Here we have a data sheet where we collect for the two main groups, sifter, roller mill, and filters, the difference on maintenance, stopping time, and others, which is any expected downtime, between a standard mill with modular mill concept. Those are indicated by hour, so hour during the total stop in a year time related to a 650 tons per day. I don't want to go in details of each single line. I just want to drive your attention to the 42 for the last row, the 42% reduction. 42 is the average reduction that we have considering all those items. And the 42% on that specific case drive to a saving time, which is converted in production about 10 extra production day with overall condition. So 10 extra days that can be converted in economical assumptions. 10 extra days is about 6,500 tons per year more capacity, 5,000 tons more flour considering 77% extraction, which is about 1.8 million more potential incoming with a flour price of 350 euro per ton. And this, assuming a revenue before taxes of 15%, drives you to 270,000 extra gross annual profit. Not bad, I think. So the numbers are indicative, related to the European market, but they can be changed according to geographic region, cost of the flour, and so on. But in the end, the concept is that we will still having the delta related to the modular mill concept. So, in conclusion, all the numbers that we have are, I am sure, are conservative numbers. Maintenance hour, considering that the plant becomes old year by year, the time for maintenance will increase. So the benefit of modular mill concept will also increase. The economical assumptions are just based as a source of revenue for flour and not considering the byproduct. So we will have other incoming on that one. And another important, I think one important point, that those revenue are for the entire life of your plant. So we are talking for next 30 years, you will have those benefits, okay? And the benefit that we are considering now, they are just the one easy to understand and to quantify. But as we see, there are many others benefits that are not so easy and that we are not considering in this evaluation. So all those together will have a really good impact in the total cost of ownership that we'll have. So in the end, considering all those aspects, the modular mill concept is the technology that could make a very big difference in a competitive market like we have today. But in the same time, this is a technology that could boost our industry to obtain savings, energy consumption, emissions, that are the demand that the markets have. So we have to make attention on our environment. So this is a small step on that direction. That is all for me. I would like to thank you all for the attention to be participating. And if still having some question, I will try to answer in the time that we're still having.
Yes, thank you, Marco, for your presentation. We have a lot of questions now. We start from the first one. Do you recommend one MMC instead of two smaller mills when different varieties of wheat are used?
When two, sorry?
Do you recommend one MMC instead of two?
Okay. Depends on how frequently you change. What I will say is that today, change a production in a big mill is not a big deal. So we can switch from soft to hard or vice versa in a quite easy way. So depends on how often you change it, but I will be not afraid to have a large mill and changing capacity and changing production from those two.
Are the downtime data theoretical or confirmed in operation of an existing mill?
The downtime that we have is the numbers that we collect for a mill which is running. So all the data related to maintenance and the downtime. Of course, this is a pretty new mill, and I don't want to go on much details related to that, but the numbers are quite real numbers.
Okay. Is this possible to apply the MMC to an existing plant layout?
In principle, yes, but we have to make a survey. So we have to analyze if there is some limitation, because we have to understand the modification that we have to do in the plant. And this one we can do only analyzing what you have. Oh. This is a fundamental, the reason why we are asking for a survey to understand, and in the end, to understand if the modification that we will suggest has a logical payback. Because for sure we can, but if in the end you spend a lot, then we will be the first to say, it's not the technology, it's better to don't do it, you know.
Okay, probably you can help me to understand what is written here, because probably it's very technical. Can you apply MMC by stages and at the end IoT, or is it mandatory to have IoT from the beginning?
No, it's something that, of course, the question is that if we are talking about new mill that start today as a project and developing, my recommendation is to already include that one. If you have an existing mill, something can be retrofitted. And also is important as a concept that the mill is scalable. So it's important also understand how much is the cost for what you are looking for. So if there is a return of investment, then it's good to spend. If there is no return of investment, or the return of investment takes long to have it, then we can postpone the investment. Is something that in certain points is something that can be retrofitted as well. I don't know if I reply, but this is the concept that we try to drive. It's easy. There are something that is nice to have, and there are something that we must have. So it's important to understand what is the division between the two.
Okay, thank you. From a construction perspective, what are the benefits of constructing a modular mill versus building out a traditional mill?
Let's say on the civil, I don't see many difference between the two. I see a lot of differences between two lines versus one. So if we go for a single line, there is not much difference on having on the construction. Of course, maybe you can save a little bit space, but there is no this big, huge, for example, 600 tons per day mill using modular mill concept technology or not using. You have a lot of benefit on day-by-day production and day-by-day benefit, let's say, on that one, on the production. You will save, this is reality, on the erection. In the erection, you can save time, but erection together start up, because you will start up with just 50% of your production. So quantify this is not easy. We have to sit and speak reality on the mill, how much this, on the real example.
Okay, just congratulations for our presentation. So thank you a lot for the compliment. I thank you, Marco. Thank you, everyone who participated to this webinar, and hope to see you again with us to the next webinar. So follow us on our social pages, and thanks. Grazie.
Thank you again, guys, and have a good day.
Thank you.
Bye. Bye-bye.